This begins the first section in 214. This section, basically, we will cover measures of central tendency, that is, measures of the middle of the data set, and measures of variation. That is, how much the data is spread. We'll also look at certain measures of location, in particular the percentiles, which is close to one of the measures of central tendency. In doing this, we will look at different types of ways of arranging our data. But let's back up a little bit and make sure that you understand several things before we start this course. One is that there are two very basic types of data. One is quantitative data, that is, data that can be expressed as a number. For instance, your weight, your height, how much you have in the bank, how much income you have, how much you spend. All those can be expressed as numbers. Alright, so this is data expressed as a number. And in particular, every person, every item will have one number associated with it. What's also important in this course is qualitative data. Quality, alright, qualitative data. And that's data, information, that measures quality of an item. For instance, is a person male or female? It's a quality. Does a person wear contact lenses or not? That's a quality. Is a person left-handed or not? Right? It's a quality. Right, so we'll just express that here as data measuring quality. And this course is about actually both of these things, quantitative data and qualitative data, in ways that at the outset are very difficult to see, and perhaps at the end of the class it's very difficult to see. We're interested in things like the average of a data set. We're also interested in probabilities. And probabilities are very close to qualitative data. All right, what's the probability that I pick a person at random from the population and the person is female? All right, that's the probability of a quality of an item. All right, so quality and sometimes quantity are important aspects of the information that we'll look at. This course is all about statistics. All right. And statistics are measures of data. And we just talked about two aspects of looking at data, quantitative, qualitative. But in reality, what we're interested in the long run is taking a subset of a large data set and saying something about that large data set from the subset. Okay, so we have two things that we will talk about or allude to. One is the population. The population is all possible data elements from a given a particular definition of the entirety of the population. All right, so the population is all of the items. Sometimes it's very difficult to define a population. All right, we'll also deal with samples. A sample is a subset of the population. In our work later, we will require that these samples be drawn in very particular ways, but that also needs to wait till later. Okay. This first lesson, we're going to talk about measures of central tendency, alright, and in particular we're going to do so for, at first, raw data. Raw data is where we have access to all, and we know all the different data points in a sample or a population. Okay, this measures of central tendency mean, we want to measure for the middle of the data set. Okay, we have several measures that we'll look at. One that you should all be familiar with to some degree is the average. We'll also use the word mean as a synonym for average. Another measure is the median, and another measure less used is the mode. But a mode sometimes is a very useful way of talking about the shape of a probability distribution or frequency distribution later. Alright, first let's talk about the average, and we'll do it more likely with samples. So let's define we'll put some notation to all this. We'll use X bar as the sample average, and the formula for that, for just a simple data set, will be the sum of the x's in a data set divided by n. Or if you wanted to be really particular about that, you would fill it out and you would say we will sum the items with subscripts I being going from 1 to n. Alright, and the x will then have a subscript I, and we divide that by n. But if we leave out the subscripts and the beginning and end on the summation, just as we have done here, okay, then we just mean add all the data. Okay, and then of course later on we'll divide by n. Alright, so let's start with a particular data set. I'm going to call this data set 1A, as we might need to refer to it later. And the data goes as follows: 0, 0, 1, 2, 2, 4, 0, 1, 2, 0. Alright, there are 10 data points there. Let's assume that they refer to the number of houses sold per month for a particular real estate agent. Alright, so hopefully we all know how to take the average. Okay, so what we would do is we would add all those items and divide by the n, the number of items. make sure that we understand that this is a sample average that we're using now, and the little n is the sample size, the number of items. Okay, so let's add these x's. Right, so that's 0 and 0 is 0, and 1 is 1, and 2 is 3, and 2 is 5, and 4 is 9, and 1 is 10, and 2 is 12. Of course, the zeros don't matter. Alright, so the sum of the x's is 12, the number of data points is 10, so the average for this sample is 1.2. Now clearly, if this is the number of items of a number of houses sold per month, we can't ever see 1.2, but 1.2 is the average. In a sense, if we had a number line and drew a simple bar chart with these data points, the 1.2 is the center of gravity of the data. Alright, so that's one way in which we can describe the middle of the data. And if you think about it, it's very difficult to, in layman's terms, define the average. We've used the concept of average so long that we think it's natural, but it's still not an easy thing to define. If we were going to do this with a population, we'd use different notation, but just so that you can see it now, you'd get the same answer, of course. Mu is the population mean. Again, you'd add all the x's together, and then you'd divide by the number of items in the population, n. Okay, so mu, the Greek letter, is the population mean or average. Capital N is the population size. So let's summarize here for the sample again. Alright, x bar is sigma x divided by n. X bar is the sample mean average. And little n is the sample size, that is the number of items in the sample. Alright, let's move on and talk about the other measures. Let's talk about the median.